So we've got the cliff divers, and we know that they're 35 meters above the ocean. And so as they're diving down, we know what your potential energy, U of gravity, is mgh. And by the time they hit the water below, the only thing they'll have is kinetic energy, 1/2 mv squared. You're solving for their final velocity. So that's the final velocity just as the guy enters the water. And you're essentially going to set them each equal to each other. You might notice that we don't have the mass of the divers, but I'll bet you can figure out that it's going to cancel out. And then the trick on is that what happens to their energy once they hit the water. Now think about this. When you hit the water, what happens to the water? A rock goes in the water, a human goes in the water, it moves the water. It moves the water. What kind of energy is through the motion? But also a certain amount of energy. If you ever done a belly flop at a swimming pool, there's a certain amount of energy. What does your skin feel like once you've done a belly flop? I'll bet you can figure out what the other kind of energy is that the energy is going to be dissipated into, because you can't lose energy. It can only be transformed.